Well, hi, good morning, and thanks so much for coming and joining me in my shop here for another day of hopefully fun and interesting messing around with this radio. Yesterday I was looking at the plate of the IF amplifier to see what kind of signals are there, and I made an interesting discovery. It could have been made other ways, that the non-linearity in the tuning of this radio is really extreme, in fact. So not sure what to do about that, but I'm going to move on and take a look at another part of the radio. Just going to try to move further in the circuit, figure out how to apply the SDR to some kind of useful test point somewhere around the detector. So maybe the best thing we can do is start by taking a look at the schematic and see if we can spot a good place to try. Okay, here's the schematic. So we were testing right here yesterday, and today I want to essentially test on the output of this transformer, basically the next tuned stage, past the next tuned stage. It looks to me like somewhat limited options here. This is the volume control, so we could look at the top of the volume control. Now what's here is going to be a rectified RF signal, and the signal is going to be suppressed by this capacitor, C14. So just what we would see here, I don't know. If this capacitor is not in the circuit, or is incorrectly sized, or is worn out, it doesn't have much capacity, then maybe we'd see some RF in this area here. There'll be a little bit of DC here, a negative DC that's generated if there's a signal to rectify. There's always something. There's always some noise or something that's going to rectify in here. So I think not many choices here. We either put the test lead here, or put the test lead here, and I think this is the better spot. This is an easy place to find too, right on the volume control. Be very easy to find. Well, we'll try that and see what we get. Maybe later we can move it up to here and try this. I'm just looking at this grounding symbol here. This means connection to the chassis. It's interesting what's connected to the chassis and what's not. So the outside metal of this tube is connected to the chassis. The outside metal can of the IF is connected to the chassis, of course. It's bolted right to it. But this one I think is unusual. To me, not unusual. I don't fully understand why this just doesn't return to B minus. But I'm not going to study that right now. This one's similar. So exactly why this is done this way, I don't know. It's very common in radios. They use a B minus line, that parts of the front end are actually onto the chassis. Don't quite get that. That's okay though, I don't have to get everything. Okay, well, so we'll hook up the SDR here and we'll see what we get. Okay, I've got everything connected up here. I've got the SDR antenna connected through a capacitor to the volume control, which is just on the end of a wire. Down here's the volume control. There's a wire that comes up, and I've hooked up here. It's just a convenient spot. And let's first find out what's this done to the radio itself. So I'm make and break this connection. Not much. Seems to take away a little bit of the trebly part of the hiss we're listening to. Doesn't seem to have any effect at all. Okay, let's go see if we can tune in a station here. Well, there's a good chance. It's a good chance I've monkeyed with this radio so much at this point. We're not going to pick up any stations, but if we do, it's going to be down here. Well, now that sound is my signal generator. That's pretty interesting in itself. Look at that. So I'm tuned here just around 600. And I know you can't read the number here, but the number is... What is all that beeping about? Okay, so I won't bother explaining the beeping just now. Nothing to do with what's going on here. 1485. 1485. That would mean right now, with the way this radio is sitting, tuned, that if there was another station at 1485, that's within the AM band, we would be picking it up. That seems a little odd. Okay, well, we'll just leave that oddity aside for now. Trying to pick up a station. Let me just, yeah. No, I'm not going to tune it with the volume control again. Here we go. Signal generator still interfering with it. Really? Hey, it's working. Somehow through all this, the radio is working better and better. There's that ticking interference. Okay, what does this do? Just seemed to muffle the treble a little bit. Okay, so in terms of disturbing the operation of the radio, it would appear that hooking up my SDR this way is not really causing any problems at all. But it is knocking a little bit of the treble out. Now, why don't we take a look at the SDR and see what it's showing. Okay, so here's the SDR. This is the IF, and there's a whopper of a signal in it, showing up. I shouldn't say in it, showing up at this point that the SDR can pick up. We see a tall signal here. This is almost certainly the local oscillator. The radio is tuned at 590. Actually, it's around 610 on the dial. It's not at 590. And so this would be, say, 600 plus 460 is 1060. You can see it says 1050. So that's close enough for now. I'm not going to worry about a little bit of misalignment because I've been doing stuff to this radio. Okay, what can we find out? What can we find out at this point? What are we actually looking at? We're looking at the point at which the radio has rectified the incoming RF signal. There is a capacitor which should be knocking out the RF, and what should be left behind is just audio. But certainly there's a very large signal here for the local oscillator. That's an RF signal. And there's an awful lot of stuff down at 460, which is also RF. The audio is not going to appear on here. I'm pretty sure I can't make the audio show up. Can I really? If this goes right down to 0, can you actually see the audio? I can't imagine it. It would be way down around here somewhere. There is kind of a funny wiggly line right here. Okay, let's take a look. Why not? The whole idea is to explore these things. I'm going to zoom way in on the bottom of the range of the radio. Now, can the radio really process a 5 kilohertz signal as if it's a radio signal? What do we see here? If the radio can show audio, it would be showing it right in this area here. Why don't let's turn up the radio. How about I'll swing the signal generator so we do have an audio signal coming out, a nice clear one. Let me okay, so that's one of those harmonics or something. We want to go right down to where the radio is tuned, 700. 600. So we're going to dial in 600 here. That was 460. Okay, I don't see anything on that. I don't see anything happening here. We come up to 600. Yeah, wait. Oh, Get out of here. Well, I'm a little stunned, but at the 10,000 hertz mark, there is a signal sitting there. Let me change the pitch of the modulation. Oh, it didn't move. It didn't move. So what exactly are we doing here? So I'm dialed in at 597. Might as well call that 600. And the SDR showing something at 10K. Turn off the modulation here. Tuning the radio. Those peaks stay there. Okay. Let me tune the signal generator again. I saw something pop up at 20,000 hertz also. No clue what's going on here. Okay, turning the signal generator. So, question would be, now that tone we're hearing fairly clearly, that's not 5,000 hertz. But there is one way above it, frequency-wise or pitch-wise. That sounds like 5,000. So I've gone past the station, tuned out the other side. Well, okay. Let me stop for a second. Well, okay, so that was very surprising. I don't know what to make of that. I'll just put that in the back of my mind for now and ponder about it maybe later. But what I would be more interested in, this is the long wave band here. This is the IF output. It's very, very strong. Now, where I'm connected, there is a capacitor. I believe its job is to drain out. That's exactly what we're seeing there, but you know, that's what I believe. That's why I'm doing these tests. So if there's the capacitor right there, they put it right on the volume control because there's a B minus line right here that's available, and then the other side of the volume control, the input side of the volume control, is where they want to drain this out. So this wire comes up here, and that's where I've hooked up. Now, would it be the case if I hooked this up closer to the capacitor? I would see much less of that IF signal? Or is it more the case that what does it really matter anyway that there's some IF signal left there? I don't know. Am I doing something there? I don't think so. What if we rotate the volume control up and down and just watch the SDR and see if changing the amount of tab off, let's say, or the amount of signal being drawn from the volume control onto the next tube. Well, the next tube is just pretty much a grid with a huge resistor usually. I can't remember this one. So it's very, very high impedance, drawing very, very little current through the volume control. Didn't seem to make any difference at all. Okay, where are we at here? So tune the radio. You can see all the action in the IF. This gives you an idea how wide the IF too is. Stuff going in both directions. Various things being. We should be listening to this. I'll go back and do this again. Okay, I'm at the end of the run. I'm going to make the red line show 460 here, just for convenience. It's not right now. There, the red line is dead on 460, so that's the center. Let me, because there's nothing going on up here right now, let's just look at what goes on inside here. This is a great view of the inside of the IF. So we got 460, 450 here, some funny signals, 470 up here. So this is kind of what I would think of as the pass band for the IF, somewhere in here. Shouldn't see too much outside of that, I would think. So here comes the signal generator, signal way off to the left. It's fairly strong coming into the antenna. Should not, I wouldn't think it'd be strangely strong. But you can hear it. I can hear it way down here. That's 20 kilocycles away from the IF. Okay, so what we're seeing, I'll tune it right in. Well, what we're seeing is the, before I say this, let me just check something. Oh. Okay, I was about to say something not true. I was thinking, first of all, these must be the tone sidebands that we're hearing, but they're way off in frequency. This is, almost 10 kilohertz. This is about 9 kilohertz out here from the center. Well, that tone you're listening to it's not 9 kilohertz. We can't quite see the top here because it's shut off. It's cut off. Let me just see if I can get the top to show here. No, it's a whoppingly strong signal for my SDR. It's too much signal here for the SDR. Can I pad it down quickly? Can I do something here to pad it down? Okay, let's disconnect. Again, hardly any difference. How about another capacitor in there? It's like a big antenna now. Didn't seem to do anything bad. Let's get this on here better. Radio's not very sensitive to this monkey business here. Well, it's going to be the same signal strength. I haven't really done much here putting that capacitor in there. Okay, well, we'll carry on for now. But maybe I'm going to have to do something to pad down the signal that's on its way to the SDR. The SDR is grounded onto the B-. If I remove that ground connection, that'll probably cause more interference to be sent into the radio. Okay, I don't think I can hurt the radio, the SDR any. Let's take this off. So that reduced it. Good. Okay. Now, what's the use of doing that? Because we want to try to see the audio sidebands that should be appearing on here. Maybe change the modulation frequency and see if we start seeing them. There they are. Okay, so right here you see the sidebands. Now the reason this is bopping up and down on my SDR is it's an effect. It's an effect of the SDR and its automatic level controls. It's trying its best. I mean, it's expecting a fairly steady state signal, like a regular transmission. And I'm not making much sense, so I'm not going to say anymore. It's just an effect of the SDR. There are ways I could change this a bit. I'm not going to bother. So there's the sidebands. What are these guys? I can't hardly see them now. I've got this down. Let's go up a little bit. Not with that, with this. What's this thing? So this is way out there. Is there any reason to even think about it? So it's a fixed signal. See that? Right around It's that same one I've come across before. It's the noise signal in my shop that is so close to the IF. It looks like 457. 450. It's very close to 455. Is that another radio doing that? Is there a radio on in here that's pumping out its IF signal? Is that what that is? I don't have another radio on in here. And I'd be really shocked if I did, and somehow its IF output signal is somehow showing up on this radio. Yeah, that's a long stretch there. Just listen to this. Listen. That's 1,000 hertz. Okay, what is this telling us? It's telling me there's more. Even though we're basically connected to the. Let's go on the schematic, and I'll show you. I'll show you what I'm talking about here. Okay, so we're connected right here with the SDR, and there is a wire that runs to the bottom of the line control. This is actually flipped around. Physically, this capacitor is located up here. So, no, that's not quite true, is it? Doesn't really matter anyway. I don't think it matters anyway. So this capacitor is connected over to what? Right here, B minus. Hard to see, there's a dot right there. So, this has the potential to kill the RF on this line. Another way of putting it is it moves the RF ground or signal ground right to here. But it's not grounded. But this means C14 is not doing its job. How big? C14 is a small guy. Assuming it's the same, it's a 330 picofarad. 330 picofarad. It's not a very big capacitor in this circuit. I'm not sure how to interpret the impedances here. The other thing is, I've just remembered now in looking at this, oh, this is done differently. This is done quite differently. That's right, this version of it uses the diode separately. This version doesn't. It's a very simple approach here. I think we should be seeing no RF here. And the idea being that you get all the energy across here because you've moved the ground up here. Like if you didn't have this capacitor, then you'd reach ground through this resistor. And this is a fair size resistor here, the volume control, 0.5 meg. So you'd have a ton left here of whatever's coming out of here. And you wouldn't have all that much left to work against these, work on the diodes. That's my interpretation of this. Maybe I need to parallel this with another capacitor and see what happens. Okay, that sounds like a good experiment. What happens if you put too big of a capacitor here? If you go too big, you're going to start affecting the audio side of things. But to me, it would be quite a difference in size. Like the RF is a long ways away from the AF frequency-wise. So I'm just trying to decide what capacitor to pick. Well, we could stick a 330 on there or something in that. We'll stick one in the range of what is expected, according to what's down here. 330. This is probably the same size. It's got the same number, C14. Okay, 330 picofarad. Okay, so I'm expecting to just sort of temporarily hold this in place, and I can't really fit it in right where the real capacitor is. So I'm going to go from up here to the B minus, which is right here. I'm trying to now. Unfortunately, I'm going to have to like hold this in the circuit and then look away. I can catch this here pretty good. This is where a big flash comes out of the radio. In, out. So it is suppressing it a little bit. In, out. Okay, what's it doing to the audio? Reducing it slightly. Well, it makes you wonder, then what if you remove that capacitor, what do you get? Well, maybe you get a mountain of a signal. Maybe you get smoke out of the SDR at that point. So maybe this capacitor is suppressing it a long ways already. It's just not all the way. You know how that works, right? You go in a messy room and you spend an hour and a half cleaning it all up, but you just do like a 95% job, and you leave a little bit of the mess behind. Now it's 95% better, but if you leave the room and come back in, it doesn't look like it. Now you see the 5%. The 5% swells to become the new 100. It's kind of like that's going on here. What if I put a big capacitor in that spot and really try to knock down? Let's try this big guy here. So this is a 0.002 microfarad. It's 100 times bigger. It's much bigger. I don't know how much it is. In this case, I'm sure we're going to affect the audio. We'll see what happens here. I'm not expecting smoke and flames. Okay. Well, it's suppressing it more. It's taken away some of the audio signal. You know something else. So with it in place, do you hear any static? Take it away, a lot more static. That's the treble coming and going, I'm pretty sure. So I think we're literally suppressing the audio with one this big. Well, there's some amount of both of these signals being suppressed, and you're just trying to target the capacitor size to knock out as much RF as you can without losing too much AF. And this is probably where design engineers can really focus and do magic in this area, but their magic costs money. You can take more components into the radio and start pushing the cost of the radio up, which of course the manufacturer is not interested in. So there's probably 1 million compromises, well, okay, not 1 million, 100,000 compromises in this radio of this sort. I'd love to cut that capacitor and see what happens without it, but I'm not going to, because this is not the right radio to do that with. So, is what we're seeing normal? Is it normal? Well, what could be better than this? None of that RF visible. I don't know. This radio is also designed because it's using basically one detector to provide both the rectified RF, rectified IF output, and the AVC voltage. If you separate those two things like the other version, and you have one diode plate working on producing the audio, the other diode plate working on producing the AVC, maybe you can improve these kinds of things a little bit. So, and what is the harm anyway? What is the harm in having a bunch of RF here? Because you hadn't made most of it. Some of the RF energy is not across the coil, the last transformer. That'll give you reduced output. So, but yeah, when I put a bigger capacitor here, it doesn't sound like you get stronger output. But you don't get stronger audio. That's what we're listening to. But we don't know about what's happening with the AVC voltage because I'm not monitoring it. And why is that? Because I'm not. That's the only reason. So let's do that. Watch what happens to the AVC. The AVC voltage tells us how much signal is coming out of the IF. And what do I need to do? I need a clip lead. Interestingly enough, we pick up that voltage right at the same spot. Now I'm going to put a big clip lead on here. Wow, it's a very low impedance spot. You can fool around with it a lot. That's what it looks like. Nothing happening. Isn't that amazing? That's a great test spot. Okay, not news to me actually. Now, take my voltmeter here. No effect. Okay, here's the AVC voltage way up on a high setting. So 15 volt scale, and we got a third of 15, 5 volts here. Is that right? 5 volts. We got 5 volts of AVC here. Now, this is with, I'll take off, no, it's capacitor protected, so there's no reason to. I'm going to put this big capacitor on. The idea is, here's the theory. Put this capacitor on, more energy across the output side of the second IF transformer. More energy means more stuff to rectify, more DC voltage. Put this on, this should go up, even if the audio goes down. In fact, the two of them would be kind of working against each other. So you might end up in kind of the same place. You know what I mean? The output's gone up, but the audio's gone down. You know what I mean? Okay, it's a seesaw effect. I don't know. What am I saying? So we're going to go right across, just making sure I know what I'm doing. That's a challenge most of the time too. You got to keep your eye on that. Keep your eye. I got to keep my eye on this. Okay, lock in one piece of this here. And reach the other. Wait a minute now, that meter jumped around a bit. It's jumping downwards if it does anything. This guy's doing some weird stuff. On the 5 volt scale, right up near the top. Let me steady my hand up here. Nothing there. Nothing there. Okay, let's go across. What happened there? So I looked away, unfortunately, and then when I look over, the meter's jumping around. Who's causing the jumping? Oh. Somebody's loose somewhere. What's going on here? My ground connection giving out on my meter. Wires breaking in here. That seems steady now. Can you see it? It's actually going up ever so slightly. It's going up the tiniest amount. Here we go. You know, like a needle width on that meter. But it goes up. It does go up. So that tells me this capacitor is doing pretty much everything that even a much, much larger capacitor would do. So that suggests to me everything's fine here, and I have no reason to think it isn't fine, in fact. that jumping around is. It could even be just a loose tube, who knows. Okay, that's a little bit interesting. What can we go from here? What can we do from here? So we're looking in the IF. Let's stop looking in the IF area. And we'll go look at generally what's happening in the radio. Let me change this here. Okay. Now, I'm just going to fiddle around over here a little bit with a decay setting. Turn the decay right off. So on the SDR now, the display is no longer going away. What's happening is any new higher amount pushes the display, the line up. Pushes the line up a little bit. So basically you end up with a peak display. Now it looks nice and stable. We don't have to go berserk looking at it. Now what about where we're tuned here? 6. So we got a 6. We got a signal coming in here. 6 something. And from the signal generator, and the radio itself is tuned. Let's get out of here. Let's go up to 1,000,000. No, 900. Go to 900. Tune to 900. Now I can kind of reset the SDR if I simply raise the decay briefly and then set it back again. So that kind of gets rid of whatever was there before. Look at basically the same pattern coming back. The local oscillator should have moved. And where would that be now? Up around 900. No, that doesn't make sense. You know what it is? It's off the scale. It's off scale. Let me shrink this a little more. Come on, mouse. That's the wrong thing. That's the right thing. There we go. Decay away and come back. This technique of stopping the decay on the SDR display is extremely helpful. You'll see tomorrow when I start fooling around with doing the alignment. How this is extremely helpful. Okay. I'm going to get it to decay a little bit. That's about the least I can do. So we should tune the radio to 900. Okay, I'm watching on the SDR. We're around 750 now. Nothing is there. $800. We're coming up on 900. 880 in fact. So you can see the signal. You can see it in the IF, but looking right around the 900 mark, alright, which is right around here. You see the actual signal generator signal moving around. So what's kind of interesting here is that when I move it high, well above 900 or well below 900, you can't really see it. It's suppressed. I come back, and you start to see it right in here. You can see the effect on the IF right away. Well, that thing makes sense, doesn't it? Okay, let's zoom in on this area here, right here. SDR tuning there. We're going to expand, expand, expand. Okay, we move the signal generator around. There would appear to be two lines on the right hand side there. Two peaks. They're getting closer. What is that about? Listen to the sound, which is garbled, and look what's in there. Look what's there. Let me tune the radio a little bit. Okay, a little hard to explain what we're seeing here. I'm tuning the radio itself. The local oscillator is way off to the right. I'm really having trouble understanding why there's something moving back and forth when I tune the radio. I'm going to stop and think about this for a minute. Right. So, out in the world, we could imagine that there is a bunch of stations broadcasting, and we could imagine that these two peaks are radio stations. They aren't, but let's just pretend they are. They aren't going anywhere when I tune the radio. If there's a signal at 925, tuning the radio isn't going to make that station. Isn't going to make the station engineer run over and tune his transmitter. Why is it moving? Meanwhile, the other one, this one here, is sitting still. Why is this one moving? Is this like something developed in the mixer as somehow bypassing the IF? There's a lot of suppression in the IF for a frequency like this. It's double 460. Double 460. Double 460 is 920. Oh my gosh, that's exactly where we are. I just happened to pick double the IF. We're looking at what's in the IF on a harmonic of the IF. Is that possible? Is that even possible? So we would just see. So if we look at the IF frequency, we should see something like. Let me put this right on this. Okay, so 460 doubles 920. So I'm going to put this right on the 920 mark there. So the radio is actually tuned to 918, that red line. I'm going to put this right on the 920. And we're going to jump down and look at the IF. 460. Okay, so 460 is right around here. Let me zoom in there. So there's something in there. You can hear the sound of the speaker. It's an unmodulated signal. Let me know. By the way, the signal generator in my shop is at 880. Okay, so if I tune the radio just a touch, you know what? This is what we're seeing here. We're seeing. Okay, so if that's the case, if I can force this onto 950, it got suppressed for a bit. 950. Let's do this more accurately. I'm going to zoom out a little further. picking a very exact frequency. Okay, so now that would be 460. We'll go 5 up, 465. Okay, still lots of signal going through the IF. A little higher, coming out of the IF, in fact. Right on 465. Now, if you double this, 2 times 465 would be 930. So if we go up looking at 930, is there a signal there? 930. Well, there is. Right over here. Okay, let me put it in center. I have to reset this. 930. There it is. And if I just move the tuning now. Oh, this radio can hear itself. Does that make sense what I just said? Not really. I think I've encountered this before. Well, okay, what if you triple it? If you triple 460, what do you get? Triple 460. That's too much math for me at this time of the morning. Triple 460. 3 times. So I'm going to guess all these effects in better and better radios are dealt with in better and better ways. And we're looking at a fairly cheap radio here. 460 times 3. 1380. Now I don't want 460. I did this. What did I did this at? Let's say 930. I have to find out where it came from. Where did you come from? That's a good question. 2 equals 465 is where I placed the signal in the IF. So times that by 3. 1395. Is it there at 1395? Well, now I'll go up and take a look. 1395. 1395. Okay, so it's off to the side. And just move it in the middle here. 1395. Well, there's something here. It could be the precision at which I'm doing this is not so great. Oh, this might answer some interesting, I don't know, it sure raises a lot of questions. Okay, tuning the radio slightly. No, I don't see anything really. Oh yeah, there is something right there. Very hard to see. It's right here right now. There's something right here. At this spot. So if you watch this peak, I'll move it over this way. There we go. See it moving? There it goes. Now it's going up the side of the hill. It's reached the red line. What did the radio do? Listen to the radio. Why would you hear this? Because the third harmonic, am I using the right term? Third harmonic of the IF frequency is placing a signal in the air that the radio can pick up. It's like listening to itself. Like this is very close to feedback, isn't it? Well, not necessarily, because it's not feeding it back, it's feeding it forward to the speaker. The IF isn't hearing what's in the speaker. Well, okay, here we are. What's the implications of this? I think there would be implications of this, potentially. So if the radio can only be tuned in one place, you can't have it tuned in 2 places. We can kind of do that with the SDR by looking across the display. So this thing is only sensitive to what it's tuned to. But if you tune it to this frequency, it will hear itself. I haven't done that. I have not done that. The radio is tuned to a little below 900. If I tuned it up to 13, 13, what was it? 1395, 1400. We'll see if it hears itself. It's crazy. Okay, 1400. Now, how do I know this thing's at 1400? Okay, we have to look at the oscillator, the local oscillator to figure that out. 1400. So we're in the range. Just a lot of stuff. How much of this stuff, the radio's been listening to itself. How much of this junk that comes out of radios like this is the radio itself hearing itself? Yikes. Okay, think, man. What do you want to do now? You want to take a break. Take a break, and then come back in and we'll make the radio hear itself. Okay, once again, I just kind of gobbled down my coffee because this is pretty interesting. And first thing we've got to do is make sure the local oscillator is set 460 away from the third harmonic of the IF. Got that? So we need the local oscillator to be 460 above 1395. So we'll look for it on the SDR here. Just broaden this way out. And we'll pull it a little down. Somewhere in there is the local oscillator. For 1395, it should be up around 19. Should be somewhere, that's probably it right there. Should be somewhere up around here. Let's see if that's where we are. Yep, there it is. Now we need it to be very precise. So I'm going to zoom in on that so we can see it better because there's just too many. I'm seeing the forest. Come on, mouse. Don't quit on me now. My phone? No. Okay. So, 1395 plus 460. No. 1395 plus 460. 1855 is where we want the local oscillator. So 1855 is right there, where the red line is. So we'll set this there. The radio may start to do something funny. Let's see. Right there. Now the humps and the thing we're seeing on the screen here, the radio can't tune that in. It looks like it is, but interesting. I've got the signal generator at 1361. That's just be some wild and crazy thing. Put this right here where it's supposed to be. So, the radio's listening now to two things. Is it? Kinda? Yeah. One would be, listening's not the right word. Sensitive to? That's not even the right word. The speaker. The speaker is listening to both the rectified 460 kilohertz IF frequency and the rectified third harmonic of that. I could do this at the second harmonic. It's a lot stronger. I got a sneeze coming on here. That blew the dust out. So I will dial up what the radio is actually going to listen to, which is 1395. Wasn't it 1395? Too many numbers. 1395. Here we go. Yeah, okay, that's 1395. Right in here. What's going on the screen? So, question might be, at this particular weird spot on the dial where the radio can pick up its own IF, is there some difference in how things sound? First, there's a whine in there. So what we'll do is we'll tune the radio down just a touch, and then I'll pass the signal through it, and we'll see what happens. So swooshy stuff, but I mean there's so much going on here. Okay, a little bit of a quieter area. No swooshy stuff. Just out on the fringe here. It'll be more interesting if you can see the meter going back and forth here. That's just a little hard for me to reach over. Well, what about this? So you see how low this is, and quiet the radio is. Go back. Oh, now that has a characteristic sound to it, to me. Like there's a, what's the word? Come on, early radios made with this technique. They basically sit on the edge of runaway resonance, runaway oscillation rather. Well, if you're a radio person, you know what I'm talking about. It has that characteristic sound to it, like if things were just a little more, it would actually turn into full oscillation. If what was a little more? So what I've learned from this is, and I've wondered this, I've never had an answer to it, what is the problem with the RF continuing on all the way to the output tube? Just junk RF making it to the output tube. Maybe through the triode in the detector tube, and maybe actually right through the audio tube right at the end. So for instance, if you allow the IF frequency of 460 to somehow get through that, what's the problem with that? Well, part of the problem with that is it's going to get stronger and stronger as it gets amplified in these audio tubes that aren't intended to be amplified there. And then you're going to have this massively strong signal that you don't really want floating around in the radio, getting back maybe into the mixer tube, where I'm pretty sure, you know, everything in there is getting mixed up with everything. And you would potentially be setting up a feedback circuit too, because you have enough signal left, because you've allowed it through and getting amplified right at the end of the radio circuitry, that it's blasting now, and it's able to leak back and set up an oscillation. It will probably lead to motorboating, because the signal is going to trigger the AVC, and the AVC will probably will throttle the radio, maybe have some other minor effects that combined, you start to get this pumping action, which may go very, more like a flutter. You know, I'm picking these things up. I don't know necessarily that they're true. They make sense to me. It's almost, in fact, I'm stating the obvious. Like a lot of things in life, they become obvious when they become obvious. And up until then, it's very hard to get your head there. I've never really read exactly this in books. And what I've read is, you know, there's capacitors in there to suppress this stuff at the end of the RF circuitry. You want to just, you know, get rid of the RF. Never a clear explanation of what could happen. Or the explanation is it may cause motorboating, but not, well, why would that happen? Because the signals are so powerful. They've been amplified so much. And you've got these harmonics coming through. I've encountered this before. Let's go down to the second harmonic and then we'll call it quits, because the second harmonic is going to be much stronger. So kind of repeat this. So go 460, 920. So tune the radio down around 920. Okay, we'll look at where the local oscillator is. So to make the radio tune 920, to make it tune 920, calculator please. If I do this in my head, I'm going to get it wrong. So we're going to go 920 plus 460. Oh, local oscillator is going to sit right on the third harmonic. 460. Oh, come on. Yeah, it's not a vintage calculator in the vintage shop here. Let's try that again. 920 plus 460. 1380. When I was working in my professional career, I was there for a tremendous change of technology in the company I worked in. Computers coming in, small computers coming in, word processor coming in. The first word processor that came into our department, we had 100 people working in our department. We had one main secretary who did the typing for everybody. It was just full of technicians and engineers and all that kind of stuff. And did the typing for us. Yeah, we still had somebody doing that. Even as computers were showing up, word processors were showing up in our hands. But the first professional one was a big Wang word processor. It's a big machine. None of us allowed to touch it. Only the secretary could touch the machine. Towards the end of the day, I happened to be standing beside the secretary, who has now learned how to work the Wang machine. And towards this, she turned to me, and this is what she said. These machines are difficult. Towards the end of the day, they're full, and the keys get harder to press. I didn't say anything to her. I didn't want to say anything to her. But so we all put models in our heads and stuff like that to try to understand these things. This is a big challenge with these radios. We have very simplified models in our heads that we've read in books and stuff like that. But the reality is a little more complicated than these simple models. And the simple models are good in a simple situation. But when things get a little out of control, the simple model doesn't help you. It gets in the way, in fact. Especially if you think the simple model is the real model. I'll just give you a hint of this. If you consider a vacuum tube, we've seen 1,000 times. The circle, and they show the plate, and they show the grid, and they show the cathode, and they show the electrons shooting through like this, and the grid is throttling them, so there's more and less, more and less. Well, that's a model of what goes on in the tube. It's not right, though. There's a lot more going on in the tube, which I'm not going to go into, but there's a lot going on between the grid and the cathode. There's lots going on right off the cathode that needs to be understood if you want to fully understand how tubes work and what weird things they do under weird circumstances. And I'm not saying I know this stuff 100%. I don't, because the simpler model is pretty much good enough most of the time. But if you've heard about tubes having a thing which is commonly referred to as a kink in their operation, you can't understand the kink without understanding more about how the tube, getting a better model. And even the better model is still just a model. What's really, really, really going on in the tube? Really? We're shooting electrons around? Is that really what's going on? I thought, according to quantum mechanics, the position of electron cannot be known. Its velocity and position cannot be known at the same time. It's a fuzzy thing. And in fact, through superposition, the electron is everywhere at the same time. And it's there until it interacts with the real world or is observed in some way through something. What about all that stuff? How does all that fit into the simple model? So the simple models we carry around in our head for all kinds of things. This is what makes human beings great, by the way, our ability to do this, to derive simplified models of how things work, and then utilize those models to move forward in the world. Even if sometimes the models are complete bullcrap, it can help us move forward in the world. We're really good at this. We're so good at it. We don't even know it. Hats off to human beings. Man, am I lucky that I'm on the earth as a human being. And man, am I lucky that I'm on the earth as a human being at this point in time. As much as people might think, wow, the world is, going to, wear in a handbasket. This is a lot better time to be alive than virtually any other time. Hey, human beings been on this planet for 200, maybe even 300,000 years. People just like us, okay? Can talk like us, can think like us, act like us, 200,000 years. And it's only the last little bit where you've been driving cars. So, wow, we're lucky. Really lucky. Of course, in the mind of all of us, human beings, right from way back when, we've all been living in the modern times. Always. Okay, getting pretty speechy here. That usually means I've drank too much coffee. So, now what we got to do is remember what we got to do, which is go for the second harmonic, tune this into 920, set the local oscillator. Wow, did I ever get off on a rant there? So I want to make the local oscillator work at the second harmonic, third harmonic frequency. So 460 times 3. Wow, I have to go right back to square one here. I got so far off there. This is the stuff I like thinking about during the day too. It's all that stuff about quantum mechanics and all the fantastic things that are being learned about the universe. So much more is known than when I was a kid. I mean, vast amounts more. And it's just the discoveries are coming so fast. 1380. Local oscillator on 1380. I'm going to lose my mind here. 1380. Yes, we should rejoice. 1380. Okay, 1380 is right around here. We need the local oscillator to be on the red line. Okay, where is the local oscillator? Right near there? Okay, right on there. Okay, local oscillators right on 1380. Which means the radio is tuned to 920. 920 is double the so there's like magic frequencies across the band, like critical frequencies that you could go to perhaps and say, hey, what's happening here? And you could hear something with the radio and go, oh, I know what that is. That's that capacitor across the volume controller. That's the capacitor that's providing the signal ground to the output, to the IF output, or something like that. I would like to have those abilities. That's really what I'm trying to do here. Okay, so we'll tune around a little bit. Nothing spectacular coming out of the radio. It's not like, doesn't sound like it's close to oscillating or anything. Okay, let me get it right back on again. 1380. Very good. Now we want to tune the radio to 920, not the radio. We want to tune the signal generator to 920. We'll see what it sounds like. Will it sound any different? Here we go. 920. 920. Sorry, my arm's in front here. Not that you can see much. Guess we'll watch the meter there. 920, here we go. 900. 910. 920. Okay, so 920. Ooh, look at that meter go right over. We got a lovely result. Now, is there something funny about the radio operating right here? I'll tune the signal generator back and forth. Well, there's a swoopy sound, but swoopy sounds all over the place. We'll go down a little bit. Well, the swoopy sound is suppressed quite nicely. The swoopy sound is suppressed by the AVC. You know, this is probably one of the keys to these radios, is that all the nonsense goes away if you have a strong station and you desense the radio so the nonsense becomes quiet. And since nobody spends time listening between stations, whatever nonsense is between stations when the AVC is low and the sensitivity is high, well, who would care? Only if the radio breaks into oscillation would anybody care. When I'm listening to shortwave, I turn off the, I have a radio, I can turn off the AVC entirely and take manual control over the RF gain. And that's a wonderful way to listen. Only when I started doing that, this is many, many years ago when I discovered this, because I had a radio I could do it with. It's a big tube Hammerland radio. Did I realize that between stations there isn't a pile of noise. These radios turn themselves up between stations, and so the noise comes way up. So as you tune out, as you tune in, it goes away. It goes away because the radio sensitivity is going way down. But if you stop the AVC, the radio doesn't strengthen up between stations. As you tune along, it's just nice and quiet, and then the station just comes out of the quiet. There it is. It's a totally different experience. And you can't turn the AVC off on these radios. So all you've ever listened to is just one of these kind of guys, or okay, you're not listening to those kind of guys, like one like this. This does the same thing. AVC in here cranks it up between stations so you can hear all the noise and all the nonsense. But you can't recognize the nonsense. It sounds like noise. It sounds like individual, discrete sources of noise, maybe in the environment. I always imagine what's going on is I have a wall wart or something generating a frequency of noise and many, many harmonics of it, which is probably true. But maybe some of that stuff you hear as you tune the radio, some radios do that as you tune up these kinds of radios, as if they're going past a succession of harmonics of interference signals. Maybe it's actually the radio itself doing stuff. Okay, that's enough for my head. That's for sure. That's more than enough for my head. It usually takes me like 10 times through something to really get it. So I'm going to probably repeat this with a lot of radios, this kind of testing. And snoop around, and then maybe we'll find radios with defects that can be detected this way by doing these kinds of tests. But I'm kind of exhausted myself here. So, well, thanks very much for watching today. There's a lot of stuff coming at you, coming at me, and I need time to process it. But I'm probably going to be doing housework shortly. So anyway, well, thanks a lot for watching. And tomorrow I'll just, I don't know, we'll go further. We'll see how far this RF stuff actually goes in this radio. See ya.